So today I'm going to be solving a bunch of AS level organic chemistry questions. So let's get started. I guess the paper that I am going to be doing the organic is February March 2024. If you guys want to check out. So let's get started with the questions. I thought they were tricky, so why not, solve them together. The formula shows the repeat unit of an addition polymer. This is the polymer that's given. What is the correct name of the monomer from which this polymer is made? Okay, so first to understand the monomer, we gotta draw the repeat unit in proper form. Okay, so over here I can see a carbon. I'm gonna draw a carbon, then I can see a hydrogen above. Okay, and then I can see a CH3 group, something like this. That's bonded to a carbon. This carbon I'm drawing with an H above, and this entire group, the group that's in the bracket is going to be below this. So it's CH2 and CH3. Done. And now there are two extension bonds like this, right? That's what they have given us in the question. Okay, that is what we're given with. Now, in order to make the addition polymer, what we did was we broke a double bond. The double bond was between this carbon and this carbon. We broke this double bond to make this addition polymer. So now, in order to identify the monomer from which it's made, we need to make the double bond again. So what are we gonna do? We're simply gonna erase these extension bonds and draw a double bond here, right? This is the monomer that we use. Now we need to name this monomer. How are we gonna name it? Select the longest carbon chain. Okay, I'm gonna select the longest carbon chain. So this, I start from here like this, and this. So that's my longest carbon chain. In my longest carbon chain, how many carbons do I have? That's the second thing. I have 1, 2, 3, 4, 5 carbons. Since I have 5 carbons, so that's gonna be pent. On the second carbon, I have a double bond, so that's going to be pent 2, and since I have a double bond, you call a double bond ene. So the monomer is pent 2-ene. I hope you get it, which makes option C the correct option. The next question says hydroxyethanol. This is hydroxyethanol. Let's draw hydroxyethanol. So we have a carbon. This is the carbon. With that we have an OH attached, something like this, and then we have H2 attached to it, H, and then we have a CHO. So C, double bond O, and H. Over here some people might think, that this CHO, for this CHO, I drew a double bond here, right? I made a double bond. But for this COH, I did not make a double bond. Why is that? Some people might think this, but you need to realize the small bits. You know what are the small bits over here? Look, if this CHO, if I don't make this double bond, for instance, first you make the single bond, you're gonna realize it's not being balanced. Carbon is only making 3 bonds. That's why I'm forced to put a double bond here. But over here for this carbon, you realize that there's a CH2 over here. That means carbon is already making 2 bonds here and 1 bond with another carbon. So this bond has to be a single bond. Okay? And if I do it right, then it should be over here and an H over here, something like this. Okay? So that's how this molecule looks, which is hydroxyethanol. Why do we call it hydroxy? I guess that's clear. We have an OH part over here. And why are we calling it ethanol? Because we have C double bond OH at the end. Okay. Hydroxyethanol is heated under reflux. Heated under reflux, not under distillation. There are two types of heating under reflux and heating under distillation, with an excess of acidified K2Cl2O7. Okay, so what kind of reagent are we using? This is an oxidizing agent. So we are basically heating our hydroxyethanol with an oxidizing agent until no further reaction takes place. What is the skeletal formula of the organic product that's going to be formed? Okay, simple. simple that we have an oxidizing agent. Now what are the two functional groups? We have an aldehyde functional group, okay? So this one right here, this is my aldehyde functional group, and this one right here, this is my alcohol functional group. Now I'm heating both of them, or I'm oxidizing both of them. You know that what kind of alcohol is this? A primary, a secondary, or a tertiary? What alcohol is this? This carbon, this is known as the alpha carbon that's attached to OH. This carbon has two hydrogens attached to it. And when a carbon has two hydrogens attached to it, that's a primary alcohol. Okay? This one right here, this alcohol, this is a primary alcohol. And whenever primary alcohols oxidize, what do you form? So what's happening is this primary alcohol is being oxidized. So what are you going to form? First you're going to form aldehyde, and then you're going to form a carboxylic acid. So that happens when you oxidize the primary alcohol. First it gets oxidized to an aldehyde and then into a carboxylic acid. So over here we're going to form a carboxylic acid. Okay? So let's draw. This H remains here, this H remains here, and after the oxidation what happens is that this is going to convert into carboxylic acid. So what do? C double bond O, and then C double bond O, OH, like this. Okay? And over here, what are we going to do? This part, which is an aldehyde. What happens when aldehydes are oxidized? It's written above. When aldehydes are oxidized, they convert into carboxylic acid. So this aldehyde is also going to be converted to a carboxylic acid. So what's going to happen? C double bond O, and H. Done. What skeletal formula is shown by this thing? Definitely not this. Definitely not this. And over here you can see the 3 carbons. We have 2 carbons. We're not increasing the carbon chains. 1, 2 and 3 carbons shown over here. Definitely not this. So I guess over here we have 2 carbons and both of them are forming carboxylic acid. So it's going to be option number B. I hope you get what I'm trying to do. Over here, this one's forming an alcohol. There's no carboxylic acid over here. So that's why option B is correct. Okay. Question number 37 states, compound Z is formed by the reaction scheme shown. Okay, so what do we have? We have an halogenoalkane. We're warming it with KCN in ethanol. What's going to happen? You know what's going to happen. This Br is going to be replaced by a cyanide. Okay? This potassium cyanide. It's going to be replaced by nitrile. Then we form a compound X, and then we have reflux with dilute HCl. You know, when we have HCl, we do acidic hydrolysis of a nitrile group. It converts into an acid group. Okay? I think that's crystal clear. The answer, you don't even need to think. If you guys have to give your AS level in this May, June or whenever, please just look at it and tell me the answer. If your reactions are on your fingertips, I don't even need to think. Okay, but still for you guys, I'm going to think. Just by looking at it, I can jump onto the answer, but let's solve it. देखो, अब यहाँ पे there are 2 carbons, ठीक है? And now when you add CN to it, what's going to happen is that the chain length of carbon is going to increase, and this Br is going to be removed, and instead of Br, you're going to have a CN. So what's going to happen? You're going to form CH3, compound X is going to be CH3, CH2, CN. Done? Now, whenever you do acidic hydrolysis of a nitrile, what happens is it converts into a carboxylic acid. So compound Z is going to be a carboxylic acid with 3 carbons. So let's draw carboxylic acid with 3 carbons. So because we have 1, 2 and 3 carbons in this chain. So a carboxylic acid with 3 carbons. Here you go. So that's propanoic acid. This thing is propanoic acid, okay? So that was what we had to draw, and I think this option D tells propanoic acid. This is ethanoic acid, and this one right here is compound X. They're asking about compound Z, and this one right here, I don't know Why did they give this option? Makes no sense. Okay. Structural isomerism only should be considered when answering this question. Okay, how many compounds with the molecular formula C5H11Br are primary halogenoalkanes? Okay, we only got to consider structural isomerism. In structural isomerism, there are three more types. Number one is chain. Number two is functional group, and number three is position. Okay? So first, let's try to do it with position. So C5H11Br. So what are we gonna do? Okay. So let's try to draw it with, first we're gonna see for position. I'm gonna try my best that I draw perfect isomers. First position C5. So C5, 1, 2, 3, 4, and 5. The first thing that I'm gonna do is place a Br over here, and that's my primary halogenoalkane. If I try to change the position of my Br to the second carbon, that's gonna form a secondary halogenoalkane, which I don't want. Okay? So now done. Now I try to add chain to it. 1, 2, 3, 3. Over here a chain and then a Br. Okay? I try to add a chain and then a Br. Okay? Now done with my second. Now I'm gonna continue with what I'm doing. I add one more chain. 1, 2, 3, 1, 2, 3, 4. अच्छा 5 वाला ही है. ठीक है. ओके सो नहीं अभी पूरी चेन्स को हम ज़रा कंटिन्यू रखते हैं. एक यहाँ पे सी आएगा. अब चेन इस साइड पे मैंने शिफ्ट की है. फिर बी आर आएगा. ठीक है. That's how my mind works. फिर we're gonna reduce the chain length to 3. Okay, so now C. नहीं फर्स्ट पे तो चेन बना नहीं सकते. So that's how my mind is working right now. C B R. Okay, so how many I've done so far? 1, 2, 3, 4. So I am officially done with 4. 36 का either it's gonna be A or B, because मुझे नहीं लगता 7 या 8 बनने वाले हैं. 4 मैंने बना लिए हैं. चलो और बनाने की I'll try कि मेरे से और बन जाएं. So what do? मैंने प्राइमरी बनाना है. So is there another way I can do it with functional group? नहीं मैं functional group तो change कर ही नहीं सकती. Can I do with chain? तो मैंने डाल दी है, और जितनी chains मैं डाल सकती थी मैंने डाल दी हैं. यहाँ पे मैंने chain डाल के change करके देख ली. यहाँ पे भी chain डाल दी है. Can I do position? If I change तो it won't remain primary, it will become secondary. So that's all I could do. So my answer is gonna be option A. And I showed you my entire thought process, my working, how I talk with myself doing it, and that's where I arrive. Okay. Esters can be hydrolyzed with aqueous alkali or aqueous acid to form two products. Okay. The table compares the two methods. Now I'm going to tell you one thing. Dekho. You have an ester, and when you break it down, what do you form? You form an acid and you form an alcohol. Okay? Esters acid or alcohol se bante hai na. Ab listen to me. If you are breaking your esters down into acid and alcohol in the presence of an alkali, what's going to happen is that the acid that you're going to form is going to react with the alkali, and what you're going to form is a salt and an alcohol. Okay, you're gonna form a salt and an alcohol if you do it in the presence of an alkali. But if you do it in the presence of an acid, okay, if you do it in the presence of an acid, what's gonna happen is that the acid cannot react with the acid. So what's gonna happen is you're gonna form a acid and an alcohol. And since you're gonna form an acid and an alcohol, this is gonna be reversible. This can change back into the ester. Okay? This acid and alcohol thing can change back into your ester. But over here, since salt is formed, this is non-reversible. This cannot be reversed back and form ester. Okay? This cannot be reversed back. So aqueous alkali, complete conversion to a salt and an organic acid. No, an organic alcohol. Complete conversion to a salt and an alcohol. Yeah. This one's correct. These two are correct. Okay. Aqueous acid forms an equilibrium mixture with an organic acid and an alcohol. Yeah, it's going to form an equilibrium mixture. Okay? Why? Because look, you have acid, you have alcohol, both can convert back to ester. You have ester, can convert back to acid alcohol. But over here, a salt is formed. Salt cannot be converted back to an ester. Which reagent gives a positive result with propanone? Dekho, toluenes and phenolings, they react with aldehydes. This thing and this thing is gonna react with your aldehyde. So definitely not C and D, because propanone is a ketone. Now let's draw the structure of propanone. Propanone is 3 carbons. The center one has a double bond. This has 3H like this. It's obviously going to be alkaline I2. How do I know it? Because for alkaline I2 to give a positive result with anything, it should have a CH3 and a C double bonded O. Okay? This thing is gonna make alkaline I2 give a positive result. Okay? So alkaline I2, bromine is not gonna react with it. There's no alkene or double bond over here. In which pair will each compound give different visible result with alkaline I2? In which pair will each compound give a different visible result with alkaline I2? Oh, are you seeing what's happening over here? Dekho, over here, let's draw the structures and then I'm gonna explain it to you. Now, look, for first I'm drawing for A. A has a CH3, CH2 and an OH. Okay. This thing, it has a CH3, CHOH. It's gonna give you with alkaline I2, but this thing right here, which is C double bond O, CHHH and H. This thing is also give, but both of them are gonna give you yellow precipitates. You gotta realize some things, okay? Both of them are gonna give you yellow precipitates. Why? Because how does iodoform test work? Iodoform over here is gonna give you yellow precipitate because of this thing, okay? Because of this thing, okay? And over here, iodoform is gonna give you yellow precipitates because of this thing. So both is gonna be yellow precipitate. We wanted different results, okay? अब इन दोनों पे आ जाओ. Over here, iodoform is gonna give you yellow precipitates. Over here, देखो ये वाली चीज़ है ना, CH3 ये देख रहे हो, CH3 C double bond O, iodoform yellow देगा. Over here, देखो CH3 C double bond O, iodoform yellow देगा. ये अल्कोहल है ना, तो अल्कोहल में जो O होता है वो ऊपर तो डबल बॉन्डेड O होता है ना. इधर क्या है हमारे पास, इधर देगा कि नहीं? लेट्स ड्रॉ इट. ये देखो C डबल बॉन्ड O है ना, अल्कोहल के साथ तो iodoform टेस्ट देता ही नहीं है. याद आ गया, अल्कोहल के साथ तो iodoform टेस्ट देगा ही नहीं. It does not react with alcohols. नो टेस्ट. अल्कोहल कह रही हूँ, इट इज़ नॉट रिएक्ट विद एसिड्स. ये तो एक एसिड है, एसिड के साथ आइडोफॉर्म टेस्ट नहीं देगा. ये भी एक एस्टर है, एस्टर के साथ भी टेस्ट नहीं आएगा. सिर्फ अल्कोहल्स के साथ आएगा, एथेनॉल के साथ या अदर सेकेंडरी अल्कोहल्स के साथ आएगा, या फिर आपके पास एल्डिहाइड्स के साथ आएगा. ठीक है, या एल्डिहाइड्स के साथ आएगा. कीटोन्स के साथ आइडोफॉर्म डज नॉट गिव एनी टेस्ट. ओके, ओवर हेयर वी हैव ए, इसके साथ आएगा तो एथेनॉल है, और इसके साथ भी आएगा कि नहीं. C2 इसके साथ नहीं आएगा. क्यों नहीं आएगा इसके साथ? बिकॉज इसके पास CH3 नहीं है. देखो ये क्या है, C2H5. आई शो यू इसके साथ क्यों नहीं टेस्ट आएगा. 1 2 3 4 5 C डबल बॉन्ड OH. मैंने आपको क्या कहा था, आइडोफॉर्म के टेस्ट आने के लिए क्या होना चाहिए, CH3 C डबल बॉन्ड OH होना चाहिए. ठीक है, पहले आपके पास इससे पहले इस C डबल बॉन्ड O वाले कार्बन से पहले यू शुड हैव अ CH3. यहाँ पे चेक करो, C डबल बॉन्ड O वाले कार्बन से पहले C2H5 है, CH3 नहीं है. समझ आई? ये CH3 होना चाहिए आइडोफॉर्म के टेस्ट आने के लिए. यहाँ पे C2H5 है, C डबल बॉन्डेड. तो यहाँ पे आपके पास कोई रिजल्ट नहीं आएगा. और अल्कोहल के लिए अगर टेस्ट आना है तो ये वाली चीज़ होनी चाहिए, और ये वाली चीज़ चेक कर लो, इसके पास है, डी के पास है. डी एग्जैक्टली यही तो है, एथेनॉल. सो इसमें रिज़ल्ट नहीं आएगा, इसमें रिज़ल्ट आएगा, तो दोनों डिफरेंट हो गए. समझ आई? और सी में दोनों में रिज़ल्ट नहीं आएगा. दोनों एक एस्टर एक एसिड है. एस्टर और एसिड्स तो आइडोफॉर्म टेस्ट नहीं देते. सो डन. हाउ मेनी मोल्स ऑफ ऑक्सीजन आर नीडेड फॉर द कंप्लीट कंबशन ऑफ 1 मोल ऑफ this tertiary alcohol? अच्छा चलो, लेट्स ओपन इट. C3H9 फिर C फिर OH, C4H10O. ठीक है, so now let's combust it. How? For 1 mole ना, moles of oxygen 1 mole. Okay. C4H10 O की कंबशन करनी है. कार्बन डाइऑक्साइड और वाटर बनेगा. 4 मोल्स बनेंगे कार्बन डाइऑक्साइड के. हाउ मेनी मोल्स ऑफ वाटर आर वी गोना फॉर्म? 5 मोल्स ऑफ वाटर. 4 2s are 8 plus 5 13 6.5. Okay, so it's going to be option B. Why is it going to be option B? Because you cannot change, you cannot change the. ओ नहीं 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 नहीं, यही मैं देख रही थी. यहाँ पे भी तो ऑक्सीजन है. सो इट्स गोना बी 6. एग्जामिनर जस्ट गॉट इस. बहुत मुश्किल से हम बचे हैं इस क्वेश्चन में. 6 इसका आंसर होना चाहिए, बिकॉज हमने ये वाला ऑक्सीजन मिस कर दिया. प्लीज़, अल्कोहल्स में सबसे बड़ी गलती पता क्या होती है, एक ऑक्सीजन मिस हो जाता है. प्लीज़ ये गलती ना करना. Next question says that X is an organic compound containing elements carbon, hydrogen and oxygen only. Okay, no option has any other element, so this information was totally useless because we cannot see any other element apart from like carbon, hydrogen and oxygen. If there was a sodium over here or here, I could probably eliminate it, but now I cannot. So why did you tell this information? I don't know. Cholo. The table shows the observations made from 3 chemical tests carried out on X. You add sodium, you get effervescence. You add sodium carbonate, you get effervescence. So we are either talking about an alcohol over here, because both alcohols are going to give you effervescence with sodium, or an acid. With sodium carbonate, it's definitely an acid is going to give, not an alcohol. So it might have alcohol and acid, or it might have an acid only. Hot H plus Cr2O72 negative remains orange. That means either we have a, look, if we have a primary or secondary alcohol, it's not going to remain orange. Why? Primary alcohol going to convert into carboxylic acid, and if we have a secondary alcohol, it's going to convert into a ketone. So either we are talking about an acid over here, acid not going to convert into anything, not going to be oxidized, or a tertiary alcohol. Remember, tertiary alcohols don't convert into anything. So either we have a tertiary alcohol or an acid. So let's see. Over here we can see a primary alcohol, cross. Over here we see a secondary alcohol, cross. This is secondary, ठीक है. Dekho, 1 carbon, 2 carbon, over here there's a hydrogen, so that's a secondary alcohol. So either it's option D or C. Option D, C is basically, look, there's a carbon here and double bonded O. Oh, this is, what kind of group is this? This is a aldehyde group. We're not talking about aldehyde. If there's an aldehyde and an alcohol, then how come there be effervescence with sodium carbonate? Aldehydes cannot give effervescence with sodium carbonate. Alcohols cannot give. So we need a carboxylic acid. Look, over here we have a carboxylic acid group, and over here we have a tertiary alcohol. Don't comment down that, look, you said that alcohols are gonna remain orange. Bhai, it's a tertiary alcohol. Tertiary alcohol can remain orange because tertiary alcohol don't oxidize. Primary and secondary do. So that's the trick over here. It's gonna be option D. Okay, in the hydrolysis of bromoethane by aqueous NaOH, what is the nature of the attacking group and of the leaving group? Okay, hydrolysis of bromoethane. Let's draw bromoethane. Okay, H, 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 H by aqueous NaOH. Okay, so you have NaOH and that's aqueous. So what happens is that, look. This OH, it's gonna replace this bromine, and you're gonna form a primary alcohol. Okay, so what happened? This bromine, you know what is this? This is a nucleophile. Bromine, bromides, electron rich. So it's a nucleophile, and you know OH negative. It's gonna attack this OH negative nucleophile. So I personally think it's gonna be D. Okay. Which statement is correct? Bromoethane reacts with NaOH to form ethene as a major product. Bromoethane reacts with NaOH. It was not ethene. We're going to form an alcohol. It's going to be ethanol. So, incorrect. Next statement. 1 chlorobutane reacts more rapidly than 1 bromobutane. No. 1 bromobutane is going to react more rapidly because, you know, bromine carbon bond is weaker. Chlorine carbon bond is stronger. So, chlorine and carbon bond going to take more time to break. But chlorine and bromine and carbon bond going to break easily. So, this is more reactive, which makes option 2 incorrect as well. Okay. Hydrolysis of this thing, which seems like a tertiary halogen alkane, occurs mostly by the SN2 mechanism. For tertiary halogenoalkanes, we use SN1 mechanism. So this is incorrect. A CH3, CH2 plus sign is less stable than this. Yeah, this is correct. This is primary carbocation. This is primary carbocation and this is tertiary carbocation. You know, tertiary carbocations are more stable. Primary carbocations are less stable. So I don't think this needs any explanation. That for 29 option D is gonna be correct. ठीक है, simple था. A sequence of reactions take place. The major product is compound C. Okay, चलो let's see what's happening. Propanoic acid है, LiAlH4 डाले, क्या बनेगा? Propanol बनेगा. Propanol क्यों बनेगा भाई? Because when we have acids and we use a reducing agent, we reduce acids to alcohol, so we're gonna form propanol. Now we add concentrated H2SO4 to propanol. What happens? We form a propene. Why? Because we are taking out the water. Concentrated H2SO4 is a very strong what kind of agent? It's a very strong dehydrating agent. So we're basically taking out water, and when you're taking out water out of the alkali, what's gonna happen? It's gonna of alcohol, it's gonna form an alkene. So देख लो, ये आपका क्या है? ये आपका है प्रोपेनॉल. ठीक है, बना देती हूँ. This is your propanol. Okay, so what's gonna happen is that this OH and this H, they're gonna be removed. Okay, they're gonna be removed like this, and a double bond is gonna be formed here, forming propene. Now pass vapor with steam over H3PO4. Now we're again gonna form propanol, but this time we look. This time we're gonna form propan-2-ol. Why? Because when we have steam and we have to add steam over here, H and OH has to be added, and you know the more negative part is gonna go towards the carbon that has less hydrogens, and this carbon has 1 hydrogen and this carbon has 2 hydrogens, so OH is gonna go over here because that's Markovnikov's rule that the major product is gonna be the one that has negative part on the carbon that has less hydrogen. So OH over here and H over here, and you can see it for yourself. 1 2 we form propane 2 all. So option D. Oh bhai, this was so good question. That from propanoic acid, how did we make propan 1 all, and then how did we make propan 2 all? Nice question. Okay, butene reacts with cold dilute acidified KMNO4 to give product X. What's gonna happen is that we have an alkene, we're making it reactant with cold dilute acidified KMNO4, it's gonna be oxidized to form a diol. And what we're gonna form? We're gonna form butane 1,2-diol. Which statement about the product X and the product Y is correct? To give product X, butene will react with hot concentrated acidified KMNO4 to give product Y. The product X is going to be butane 1,2-diol. What about product Y? Let's see. So butene is something like this. H and CH3, CH3 and an H. Together this is butene. Now what happens is, you see your carbon has how many hydrogens attached to it? It is one hydrogen. Okay, so it's gonna form a carboxylic acid. So this part is gonna be oxidized by the hot KMNO4 to carboxylic acid, and the other part is also gonna form carboxylic acid. So basically gonna form a carboxylic acid over here. So let's see. 2,4-DNPH. 2,4-DNPH is only going to react with aldehydes and ketones, and we don't have any aldehyde or ketone. Neither product X nor Y will react with 2,4-DNPH. Yeah. B is going to be correct. Because acid and alcohol don't react with 2,4-DNPH. I don't read the next ones. I have full confidence in what I'm doing. The drug cortisone has the formula shown in addition to those chiral centers marked by an asterisk. Okay, in addition to those marked by an asterisk, how many other chiral centers are present? Let's see. This one's a chiral. Okay. This one's a chiral. This one's a chiral. That's all. 3 more. So D. Simple tha. For chiral, what do you need to look? 4 different groups, 4 different groups, 4 different groups, and it cannot be a double bond. Easy tha. Okay, this is cholesterol. A student states that 17 carbon atoms in the 4 rings all lie in the same plane. All lie in the same plane. Nahi. They cannot be all in the same plane. Only this and this lie in the same plane because they're going to be trigonal planar sp2 hybridized. All of the rest, they are sp3 hybridized. So this one, student 1 is wrong. Student Y stated this molecule displays cis trans isomerism at the C double bond O. Okay, so it's going to display if it has different groups attached to it. So this C and this C, let's check. Over here it has this entire thing attached, and below it has an H attached. Okay? This carbon right here, above it has this thing attached, and below it has this thing attached. So it's going to show cis trans because there are 2 different groups attached. Okay? Always look for different groups when you are dealing with cis trans isomerism. So which student is correct? Both X and Y, neither X and Y. No, only this one is correct because he's saying that this displays cis trans at C double bond O. Yeah, it's gonna, because it has different groups attached, and they're not in the same plane, because to be in the same plane all should be sp2 hybridized. So these are in the same plane, but the rest there sp3 hybridized. Student X nahi, student Y sahi tha. Ye wala sahi tha. So D. Done with all the organic. See you in the next video.